this is our work on number 1, looking at this first table with some whole numbers and some decimals. If I were to plug 2 in for x and say 3 times 2, would the result be 5.5? What is 3 times 2? 3 times 2 is really 6. So if there's a mistake in one part of the table, then the whole table is off. I'm not going to worry about circling that one at all. The second table, x is a decimal number 2.5. If I were to think about multiplying 3 times 2.5, I might write it like 2.5 times 3. Where I know that 3 times 5 is 15, 3 times 2 is 6, and one more would be 7. But my estimate is 3 times 2 should be close to 6, not 75. So this is going to be 7.5. So these numbers do follow the times 3 pattern. I want you to pause the video. I want you to, on the margins where you have room, multiply 4.5 times 3, 5.5 times 3, 6.5 times 3 to see if you agree with these y values. If you agree with them all, then we'll be circling this table as one that represents y equals 3x. If some of them are not in agreement, then maybe we want to cross it out instead of circle it. Press pause, give it a try, and then you can press play to check your work. Well, let's see what happened when you took 4.5 and multiplied it times 3. It looks like 135, but my estimate here would be about 5 times 3, 15. So my decimal point needs to go somewhere close to 15, 13.5. So that pair matches my thinking. When you multiplied 5.5 times 3, what did you find out? That's right. It also follows the times 3 pattern. Last of all, 6.5 times 3. 19.5. So that entire table is following y equals 3x. Every time that you multiply an x times 3, we get this y value. So that table is another example of the rule. I like these patterns and tables because it looks very high school with the x's and the y's and the equations with variables, but it's really not hard. It's really just some simple addition or multiplication thinking. So that's help on number 1.